All right, so just worth clarifying what really does happen in the atmosphere. Like the warmists say that radiation comes from the surface, comes up and then meets some bits of CO2, and which then radiate back, so with the surface walls. Now this picture is nonsense, first of all, because it doesn't just go up to places and come back. It only goes up 25 metres before being absorbed in some atmosphere. And any atmosphere that absorbs it doesn't automatically re-emit what it absorbed, because that energy, that radiation is gone, disappeared, ended, finished. And it can turn into heat energy, excitation of the molecule. It can do lots of things. It could evaporate a piece of water. So it's not ready to go back anyway. So the whole idea of radiation equilibrium at every level of the atmosphere is complete twaddle. So their diagram is nonsense. It's fiction. It's rather like an Escher print, if you like, where you can draw an impossible diagram of water flowing uphill on an Escher print. Their physics is an Escher print. Okay, it's nonsense. Now, what actually happens to radiation coming from somewhere is, if this man is radiating, and I'm a piece of CO2, and I stand in front of him, I absorb this, but if I get warmer because of that, I radiate out there. So all that happens is we're just...
It's just heat transfer. It's just heat being moved along.
Yeah, well, it's...
I'm confused here. I put this one to... I mean, the different there is radiating in two particular wavelengths that have to interact with carbon dioxide.
Yeah.
And the carbon dioxide will absorb. It doesn't make it fly about any faster. It doesn't go going, it doesn't increase any temperature. It makes it spin faster. There's rotational and vibrational on board, because it's a dipole. Well, it's not even a dipole molecule. It waggles about. I can put it. Yeah. And so it either spins nominally, or it doesn't, but it certainly oscillates up and down. And that's where the energy goes. The energy goes into the actual molecule. So it's just nothing gets any hotter. It just energy moves from one place to the other.
That's right.
It then gets to a stage where it passes back to its normal energy level, and it will re-radiate the photon.
Or bump into something.
Well, I don't bump into something anyway. I mean, unless the momentum of the photon was big enough to actually shift it, I can't see how that would actually make much difference. I could, to be wrong, I'm not sure about that myself. But certainly re-radiated. My only claim to fame is I did once have like a CO2 laser, and that's how lasers work. Lasers work by absorbing and re-emitting. They don't get hot. Well, they do actually get hot, but they don't get hot for that reason. That's how it works. And so your CO2 molecule will absorb a photon of a particular wavelength of infrared, and we have specific wavelength of infrared. If it's not general, unless it's under high pressure, and it's not at 0.038% of the atmosphere, and it absorbs at these couple of wavelengths, they cause the molecule to move about. Then that falls back to its ground state, and that photon is emitted in a random direction. So the best that can be said, in my opinion, about carbon dioxide, about radiation of carbon dioxide, is it slows it down. You can see a photon that may escape from the atmosphere and do nothing at all will be absorbed and slowed for a fraction before it's re-radiated in a different direction. So that's the basic. None of this makes anything hotter.
Right. So see that is the Mickey Mouse argument put forward with the Vizin. It doesn't work. And even the proper warmists say that's true. What we say is true. So they then say, well, okay, upper atmosphere. What happens is where the radiation leaves into space, the level of that depends on the amount of infrared absorbers. So if there's more infrared absorbers, then that level is going to go slightly higher up in the atmosphere. So that means because there's a temperature drop with every 100 metres in the atmosphere as you go up, or increase as you go down, then since the level has gone up, then the temperature at the bottom will go up as well. Now that's a solid argument, except for they talk about that as being static. And there's another factor as well. But in terms of that being static, you see, it's not static. The temperature of the upper atmosphere at every level is going up and down by day. If you've got a bigger absorption, the range of fluctuation is going to be bigger. The average of the fourth power of the warmest bit plus the fourth power of the coldest bit is going to be bigger when the range is bigger. And if there's no range at all, there's no difference. So the range goes up and the average of the fourth power goes up. So the CO2 would then cause the upper levels to radiate more effectively in space. As the fourth power goes up, average of. So that would be a cooling. But there is an observed cooling in the upper atmosphere. Not a heating, which is what they would get from their model. Okay? Because the level goes up a bit and it's going to be therefore warmer just underneath. That's their model. And it is not observed.
Well, we know it's
the
true.
cooling is observed.
Is it easy to, well, no, it's true, of course. Is it easy to find such evidence
Yeah.
for the atmosphere it is getting cooler now?
Absolutely. Oh, sorry. Yeah.
Where's the
Measurements
base
been
to
done. At the last meeting in Parliament, remember? Richard Lindzen was there, and he was asked, what about the cold spot? Because it should be a hot spot. He said, it's probably a measurement error. Now people say, not a measurement error, it actually is colder. And see, my question to him at the time was about exactly that fluctuation. Now, he thought I was talking about a modulation of some radiation effect. Well, I don't know what it is. He thought I was talking about a modulation of the general lapse rate thing, which I wasn't. I was talking about a different effect in the upper atmosphere. And the other thing that stops the CO2 working anyway was even if the lapse rate, if that was true, the bottom level cools more, because with more CO2 plants grow faster, and they grow faster they do more transpiration, and transpiration is a cooling process.
And on the glaciers, if the sun is, if our black body is radiating to the glacier and melting it, if you have carbon dioxide in the way, then it won't get as much radiation to the glacier, so it won't melt so quick.
But does that work because that's shortwave radiation, and the CO2 interacts with long-wave radiation?
Well, heat is
That's
long wave,
the heat from the sun has an effective temperature of about 5,500 absolutes, whereas the heat temperature of the Earth is about what, 290 on average, and it's and therefore the peak of the radiation is 20 times longer in wavelength, 20 times less in frequency. And it's at those infrared frequencies where all the debate about the absorption of CO2 that Piers has just been going on about.
so that,
really
so what's
occurs.
melted the iceberg?
You
What's
tell
melted
me.
the
I don't know. It ain't direct. It ain't the absorption of
Well,
CO2 stopping
It's not the sun
stopping
shining
the sunshine.
Well,
it melts the frost on my lawn pretty quick.
At this time of year, it doesn't work terribly well in November or December.
Yeah. If you dropped the dirty handkerchief on it, it would not even faster, as you know.
Yes.
It might actually help.
Right, well anyway, it's all nonsense.